Okay, so tell me the difference between function and relation. Okay, let's get to work, everyone, now. Difference between a function and a relation. Who can tell me the difference?
Every function is a relation, but every relation is not a function.
That is true. So, what makes a function a function?
That every one input has a single output,
Yeah, every one input has a single output. ठीक है.
and many multiple inputs have the same one output.
ठीक है. सही है. सही है. We don't need to further narrow it down. One input, because the thing is, at one point you can only input one value, right? So yes, even if you input two different values and get the same output, that's fine. It's still a function. Okay. Sir, I asked Siri. Yeah, 0 divided by 0. Yeah, so you get a nice explanation. Probably not very mathematical, but you understand why it's not possible. Khair. So, nahin, I don't think. I think it probably asked something else then. It doesn't say 0. It simply said no. Thero, let me try. Let me try as we speak. What is 0 divided by 0? If nothing is divided by nothing, then there's nothing to divide or divide it with. And the division never happened. So my answer is no. Yeah, that's what it says. So see, 0 divided by 0 means you're dividing nothing by nothing. So it makes no sense. Okay? So I've heard people say that without finishing the whole syllabus, it's hard to solve functions questions. नहीं, ऐसा तो नहीं है, ऐसा कुछ नहीं है. ठीक है? Okay, anyway, coming back. So what is a function? With one input, you have one output. Okay, what's a relation? A relation could be a function, it could be not a function. Acha, we have two types of functions. What are those? Question for you guys. One to one and many to one. Okay, can you guys explain what a one to one function is and what a many to one function is? Let's start with one to one. With example.
So one to one could be just our like f of x is equal to 3x plus 5.
Yeah, take care. Good example. What about a many to one?
Gives one output for one input.
Yes.
For one value of x, it gives one value of y.
True, true. What about many to one?
Many to one could be a quadratic equation.
That's true. Okay, why? Because in a quadratic equation, you have many different inputs that give you the same output. Okay, perfect. What about one to many? Is one to many relation a function?
No, it's
No,
not.
it's not.
It's
Can
just
you give me an example of a one to many relation? Circles. Okay, I've already done that. Okay, great. Okay, so keeping that in mind, let's also revise domain and range. Okay, so what's domain? Domain is basically all the values that you can plug in to a function. Okay, or in other words, domain is basically the range of x. Okay, so if I ever say range when I'm referring to domain, what I mean is range of x. Okay, so I'll write that down in a bracket. Domain are basically your x values that can be plugged into a function, or in other words, it's the range of x. And when we say just the range, we mean the range of y values. It's like height and slant height. When we say just height, we mean the perpendicular height, okay? But when we say slant height, we mean length, basically. Okay? So don't ever get confused. Domain means the range of x or all the x values that can be plugged in. Range means all the output values or basically all y values. Okay? Okay, so we did some examples also. So here's a function f of x equals to 3x plus 2, and I asked you to find the range for the following domain. So when x belonged to a set of all real values, the range was also going all the way. That means it was going all the way to positive infinity and all the way down to negative infinity. However, when we restricted our domain, what happened as a result was that our range also got restricted. Okay, so how did we find out the restricted range? We plugged in the endpoint. So for example, we plugged in 3, we got 11. We plugged in minus 2, we got minus 4. And here we can see that our range is from minus 4 to 11. Okay, we did another example of an exponential function where in one part the range, the domain was all real values. So when we didn't have any restriction in the domain, We still, however, had a restriction in the range. Why? Because this exponential curve is such is that it doesn't go beyond 0. Okay, so that's why our range is not going to be f of x belongs to the set of all real values. In fact, it's going to be greater than 0, not even equal to 0. Sir, can the gradient cut through origin, or you did intentionally? Gradient? What do you mean gradient? You mean for this line? This is just a sketch. Okay, it's not an accurate representation. It's just a sketch. Okay. Okay. So, and here when we restricted our domain, how did we find out the corresponding range? We plugged in the endpoints of the domain and then we wrote them down in range form. So for example, when x is 3, y is 8, and when x is minus 2, y is 1 upon 4, and this is our range. As we can see that for this part of the domain from minus 2 to 3, this part of the curve only goes from minus 1 upon 4 to 8. Okay? So we're going to do some more examples. Okay? And my advice to you guys is that please do not form any standard rules just yet. Okay, we will be forming some standard rules today, but please don't do that just yet. Or if you feel like you've come up with a standard rule, then please run it through me first, okay, before you write it down or something. However, you won't have to write down a standard rule yourself. I will make you write it down. Okay, so let's do an example. Let's take the graph of sine x. Okay, now that we have done trigonometry, we can use trigonometric graphs as an example. Find the range of, in fact, let's use cos x. Yeah, cos x is better. F of x equals to cos x, okay, for the following domains. Okay. In the first part, let's say x is from 0 to 360. In the second part, let's say x is from 0 to 180. Okay? Okay, so I hope you all remember the graph of cos. This is what it looks like. At 0, it's 1. At 90, it's 0. At 180, it's minus 1. At 270, it's 0. And at 360, it is 1 again. Okay, so this is what I mean when I say you should know the shape of these trigonometric curves. There you go. Okay. Now, I'm going to do something and I want you guys to tell me if it's correct or not. Okay, here's what I'm going to do. So in order to find out the range, let's plug in 0 and let's plug in 360 and write the answer in range form. Okay, exactly like what we did over here. We plugged in minus 2, we plugged in 3, and we wrote the answer in range form. And exactly like we did over here. We plugged in minus 2, we plugged in 3, and wrote the answer in range form. Okay, so let's find out cos 0, which is equal to 1. And let's find out cos 360. These are the endpoints of the domain, which is also equal to 1. And that means that a range is greater than or equal to 1, lesser than or equal to 1. Does that make sense? Yes or no? It does not make sense, and it shouldn't make sense to begin with. Why does it not make sense? Why does it not make sense?
Maybe it cannot like start from 1 and end at 1.
It does not make sense because we can see right in front of us that that's not what the range is. For 0 to 360, that means that we're looking at this part of the curve, okay? And we can see clearly that the range is not from the maximum and the minimum value, they're not 1. We can see that the minimum value is minus 1, and we can see the maximum value is 1. So that means the range should be, this is incorrect. In fact, the correct range should be f of x is greater than or equal to minus 1 and lesser than or equal to 1. Why? Because we have the sketch in front of us and we can see that this is what the correct range is. Okay? But then something interesting happens. Here's what happens. If I apply the same concept over here, I get away with it. That means if I find out cos 0, I get 1. And if I find out cos 180, I get minus 1. Which means that if I write my answer like this, from minus 1 to 1, obviously I'm going to write down the minimum value first and then the maximum value after. Here I get away with it. Okay, here the answer turns out to be correct. However, if I use the same method here but plugging in the extreme points, I get my answer is not valid, my answer is wrong. But if I apply the same method over here where I plug in extreme points or endpoints of the domain, I get the correct answer. So why do you think I got it wrong over here and why do you think I'm getting it right over here? Think about it. Okay, that's a question for you guys. I will give you an explanation, but right now I want you guys to think about it. अच्छा पहले तो मुझे ये बताएं, confirm this with me. Is this answer correct? -1 to 1? From 0 to 180, that means if you only look at the first half of the curve, we can see that the range is in fact from -1 to 1. Okay, let me write down -1. Okay, so that means yes, this is correct. Chalo, you guys have confirmed it's correct. So the question is that why is it that I get away with over here and I don't get away with the same method over here? Because at 180 it's -1 and at 360 it's 1. ठीक है, correct. Because of range, ठीक है, correct. But I'm looking for a more concrete explanation. Because values repeat, ठीक है, correct. सही है, I mean, what you guys are saying is correct. ठीक है? But what I'm looking for is a more concrete explanation. Has values within 1 and -1. ठीक है, सही है, we can see that. But what does it have to do with the kind of function it is? From 0 to 360 and from 0 to 180. If you look at this entire function from 0 to 360, what are you going to say? Pick one. 1 to 1 or many to 1. If you're looking at this function from 0 to 360, what are you going to say? You're going to say it's a many to 1 function. Okay, so if you're looking at this entire curve from 0 to 360, this is a many to 1 function. If, however, I restrict you from looking at the entire function and I only restrict you from 0 to 180, now tell me, what kind of a function it is from 0 to 180? Is it a 1 to 1 or a many to 1? It's a 1 to 1 function. Okay? So, think about it. Look at the two examples that we did. This is a 1 to 1 function. Okay, here's a standard rule coming your way. This is a 1 to 1 function. In a 1 to 1 function, what we can do is, take a Fatma, I'll answer your question in a minute. In a 1 to 1 function, what we can do is we can plug in the extreme points of the domain and give our answer in range form. Okay, why can we do that? I'll answer that in a minute. Here also, we can plug in the extreme points and give our answer in range form. Okay? And yes, how do we know it's a 1 to 1 function? Horizontal line test. Okay? Again, I told you guys to do a quick recap of what we did in the last class. Okay? Horizontal line test and vertical line test is horizontal line test is what you use to distinguish a 1 to 1 function from a many to 1 function. From 0 to 360, we're looking at this entire curve, which makes it a many to 1 function. Okay, from 0 to 360, we're looking at the entire curve, which makes it a many to 1 function. Fatma, dekho, this is what I mean. If you draw a horizontal line, how many points does the horizontal line cut the cos graph? It cuts it at 2 points. What does that mean? That means it has failed the horizontal line test. And when it fails, it's a many to 1 function. Okay? Okay, but if I only look at the part from 0 to 180, that part, imagine that I just hide this part. Okay, if I just look at this part, what kind of a function are we looking at? We are looking at a 1 to 1 function. Now let me tell you, this method where you plug in the extreme points and give your answer in range form can only be done in a 1 to 1 function. Okay, I repeat, I'll write a note as well. If you are looking at a 1 to 1 function, then what you can do is you can plug in the endpoints of the domain and find the range. If, however, it's a many to 1 function, then how do you find out the range? Then your safest bet is always to make a sketch. Okay, and this is something that we're going to do in a quadratic curve or in any trigonometric curve. Okay? Now, there's another way to distinguish a many to 1 function. I'll write it down, don't worry. There's another way to distinguish a many to 1 function from a 1 to 1 function. Okay, I'll write it down, don't worry about it. If I ask you this question, this is a 1 to 1 function, right? Tell me, is it A, always increasing, B, always decreasing, or C, both? Tell me, A, B, or C? We're looking at this function. Listen to what I'm saying. Is this function always increasing? Is this function always decreasing? Or is this function doing both? How is it doing both? It's always increasing, yes. So how do you check whether a function is increasing or decreasing? You move towards the right side. As you move towards the right side, as x increases, what's happening to y? As x is increasing, what's happening to y? Is it increasing, decreasing, or both? It's increasing. Okay? So, I'll repeat. Is this function an increasing function, decreasing function, or both? A increasing, B decreasing, or C both? A. Okay. I hope we all can agree on that. Look at this function. A, B, or C? Tell me. A, B, or C? A. Very good. Okay. Now look at this function. From 0 to 360. A, B, or C? Yes, both. Which means it's a many to one function. Okay? Because it's increasing and decreasing. There's no specific pattern. From 0 to 90, it's decreasing. From 90 to 180, it's also decreasing. But from 180 to 270, it's increasing. And again, from 270 to 360, it's increasing. So that means this function, within a specific range, is doing both. It's increasing as well as decreasing. However, from 0 to 180, what is it doing? Is it only increasing, only decreasing, or both? It's only decreasing. That's correct. Which means, again, it's a one-to-one function. Okay? So let's summarize everything that I've said and write it down. Achha, I saw a question earlier that what about the arrow? Dekho, arrow, if you remember, I made to show that it will go all the way to positive infinity and it will go all the way to negative infinity. When we check whether a function is increasing or decreasing, we see what happens as x increases. Okay, so our standard rule is, let's see what happens to y as x increases. Okay. One question, sir. If we make a horizontal line at a -1 in cos x, there is only one point of intersection. Yes. Okay, I saw that question earlier as well. I thought about answering, but then I forgot. So the thing is, the horizontal line test is not to make a horizontal line at any random point. It is to test that is it possible for a horizontal line to cut the curve or graph at 2 points? If yes, no matter at what point it does that, but if it does that, that means it's not a one-to-one function. Okay? So yes, you know, one can argue that what if I make a horizontal line this long? Then it's also cutting the curve at one point. But that doesn't make sense. You have to see throughout the curve whether it's going to cut at only 1 point or more than 1 point. Okay? So I hope that answers your question. So if the line goes down, x will increase too. Dekho, even if you have a line with a negative gradient, it doesn't matter. That means it's a decreasing function. If you have a line that looks like this, that means this is a decreasing function. Why is it a decreasing function? Because as x increases, what's happening to y? Y you can see as decreasing. Okay? So it's not an increasing function, but it's a decreasing function. Okay? Acha, now whatever I said, let's just write it down. Okay? Whatever I said earlier, let's write it down. So a one-to-one function is either always increasing or always decreasing, but not both. Okay? So note number one. A one-to-one function is either going to be an always increasing function or an always decreasing function, but never both. Okay? A many-to-one function will be both. That is increasing and decreasing under a given domain. Okay, and you can make an example here. A quadratic curve is an increasing is a many to one function. Why? Because it's increasing as well as decreasing. Doesn't matter whether it's a minimum curve or a maximum curve. And just like that, any trigonometric curve that you take, doesn't matter whether it's sine, cos, tan, that too will be increasing as well as decreasing, and hence it's a many to one function. Okay. Acha, ab here's something interesting. Now pay close attention. A many to one function. First, listen to what I'm saying carefully. Okay. A many to one function can also be turned into a one to one function. Okay. How? We just saw that in action also. A many to one function can also be turned into a one to one function. How? Yes. What we do is we restrict the domain. Okay. So what we do is if I restrict the domain slightly, it will turn into a one to one function. So for example, let me show you. Let's say we have y is equals to sine x. Okay. Y equals to sine x, and the range is from 0 to 360. Okay. Now, during this range, there are multiple intervals where it becomes a one to one function. So this is what it looks like naturally from 0 to 360. ऐसे ही है. चलो एक काम करते हैं. Let's do an exercise. Okay. I'm going to write down lots of intervals, and I want you to tell me in that interval whether it's a one to one function or a many to one function. Okay. So what do you think about this? From 0 to 90, from 90 to 180. Tero, don't answer just yet. Okay. Okay, now, from 0 to 90, what do you think? From 0 to 90, is it a one to one function or a many to one function? It's a one to one function. Here it is. Okay. From 90 to 180, what do you think? It's a one to one again. Okay, let me write this down. 1 to 1. From 90 to 180, again, it's a one to one function. What about from 90 to 270? 90 to 270. What does that mean? 90 to 270 means that this is what we're looking at. It's a many to one function, are you sure? From 90 to 270. What is it doing from 90 to 270? Is it increasing? Is it decreasing? Or is it doing both? It's only decreasing. Okay, it's only decreasing. It's not doing both from 90 to 270. Okay, from 90 to 270, it is only decreasing. Okay, from 90 to 270, it's only decreasing, which means it's a one to one function. Okay, or what you can do is there's another test. Okay, so we now know two tests. Okay, one is the horizontal line test, and there's another test. The other test is the horizontal line test. So if you draw a horizontal line, remember that you're only looking at the green, the part that I've highlighted in green. Okay, not looking at any other part. So if you draw a horizontal line, no matter where you draw it, it will only cut the curve once. Okay, which makes it a one to one. What about 180 to 360? What about 180 to 360? Which means you're looking at this, the second half of the curve. 180 to 360. Is it a many to one or a one to one, or yeah, because it's doing both, it's increasing as well as decreasing. What does that mean? That means it's a many to one function. Okay. What about 270 to 360? 1 to 1. Okay. So I hope the difference now is clear. 180 to 270 is okay. Now you gotta narrow it down. Okay, what do you mean by both? Okay, because what I mean by both may not be the same as what you mean. When I say both, I mean it's increasing as well as decreasing. So 180 to 270, no, 180 to 270, it's only decreasing. It's not increasing. It's going down. So that means it's a one to one function. Okay. However, from 180 to 360, it's a many to one function. Okay, now let's use this concept and apply it over here. Okay. So domain and range are basically domain and range is a very important concept. Okay, and students usually get confused when they're dealing with many to one functions. Okay, only when you have to find out the range of a many to one function, that's when you have to be careful. For a one to one function, we saw we don't have to worry about it. Okay, we can just plug in the extreme points, find out the range. That's it. We're done. Okay, but what happens if you're dealing with a many to one function? Okay, let's see. So here's a question which says find the range of f of x equals to x minus 2 the whole thing square plus 3 for the following domains. Okay, so first part, x belongs to the set of all real values. Part B, x is greater than or equal to minus 2, lesser than or equal to 3. Part C, x is greater than or equal to 3, lesser than or equal to 5. Okay, now I'm going to solve this question. Don't worry about it, I'm going to solve this question. First of all, you have to familiarize yourself with the function that you're dealing with. Okay, what is the function that you're dealing with? You're dealing with a quadratic function. Okay, and your safest bet is always to make a sketch. Okay, so in a quadratic curve, what is the key point? Actually, you have plenty of key points. You have the x-intercept, y-intercept, turning point. But when you have the expression that's looking like this in completed square form, what can I find out immediately? What can I determine immediately when I have the expression in completed square form? That's correct. I can find out the turning point. Okay, so what's the turning point? The turning point is 2, 3. So let's say it's somewhere over here. Okay. So what does the curve look like? This is what it looks like. And remember, this is just a sketch. Okay, it's not an accurate representation. Okay, now in the first part, there is no restriction. Okay, domain is not restricted. That means you can plug in positive infinity, you can plug in negative infinity. So if I say that the range for the first part is all real values, is that correct or not? Think about it. Think about before you answer. It's not correct. Why is that? You're right, it's not correct. The question is why? When we say f of x belongs to the set of all real values, what are we trying to say really? We're trying to say that the range can take any value all the way from positive infinity all the way to negative infinity. Is that true? If you look at the curve, is that true? That is not true. Okay, why? Because the curve doesn't go beyond or further below the turning point. So what do you think will be the correct answer? Tell me, what do you think will be the correct answer for the range? Let me put a cross here. What should be the correct answer for the range? That is correct. F of x should be greater than or equal to the turning point. And what is the turning point? The turning point is 3. F of x is greater than or equal to 3. Okay. Why is that? Now, the thing is, if you remember, what do we call this curve? We call this curve a minimum curve. Why do we call it a minimum curve? We call it a minimum curve because it has a minimum value. What does that mean? If the minimum value is 3, that means all the other values of y are going to be greater than 3. Okay, which means the range of this curve is going to be greater than or equal to 3. Okay, so what's the range? It's greater than or equal to 3. Why is it not equal to all real values? That's because there is a certain value which this curve doesn't go beyond. Okay, doesn't go below that value. And what's that value? That value is 3. Okay. Any questions so far before I do part B? Okay, great. Acha. Ab let's do part B. Now first, let's do part B in a way that we plug in the endpoints, see what the corresponding values are, and then we'll see whether that is correct or not. So let's see what happens if I plug in minus 2. Okay, so if you plug in minus 2, f of minus 2, let's do it mentally. Minus 2 is going to be, minus 2 is minus 4. Minus 4 squared is going to be, yeah, it's going to be 19. Okay, thank you. And then let's plug in 3. So 3 minus 2 is 1, square of which is 1. 1 plus 3 is 4. Okay, now what does that mean? That means if you plug in minus 2, so assuming that minus 2 is somewhere over here, so minus 2 gives us what? Minus 2 gives us, let's say this is where it is. Minus 2 gives us 19. Okay, so let's say here's minus 2. It gives us 19. Okay, now pay close attention to what I'm saying. And then if I plug in 4, which is going to be somewhere over here, okay, remember it's a sketch. Okay, 4 gives me, if I plug in 3, sorry, it gives me 4. Okay, 3 gives us 4, and yeah, minus 2 gives us 19. Okay, so if I say that you're only allowed to look at this part of the curve from minus 3 to 4, and while you're looking at this part of the curve, the range is, sorry, wait a minute, from minus 2 to 3. I said minus 3 to 4, sorry. So if I allow you to only look at this part of the curve from minus 2 to 3, and if I say that the range for this part of the curve is greater than or equal to 4 and lesser than or equal to 19, since these are the values that we get when we plug in the endpoints. Is that true or not? Is that true or not? Think about it before you answer. Okay, no, that's not true. Why is it not true? You're right, it's not true. But the question is, why is it not true? Why can the range be from 4 to 19? Yes, that is the correct explanation. That's because the turning point is there, so it's lowest. Why? Because in between these two values, in between minus 2 and 3, the curve goes further below and it goes to 3. So what will be the correct answer? The correct answer will be f of x is greater than or equal to 3, lesser than or equal to 19. Okay, so this is wrong. Let me put a cross here, and let me put a check mark here. Okay, so that means when I use the method where I plug in the endpoints, I don't get away with it. But here's something interesting. If I use the same method and apply it in part C, I get away with it. If I use the same method and apply it in part C, that is f of 3 is 4, and if I work out f of 5, that's going to be 5 minus 2 is 3, 3 squared is 9, 9 plus 3 is 12. So if I use this method over here, I get away with it. I get the correct answer. Okay, why is that? And you can see that here, that if you plug in 5, this is what you get. Plugging in 5 gives you 12. So if you're only looking at this part of the curve, which I'm now highlighting using the color purple, so I'm trying to color code it here. And looking at this part of the curve, if I say that the range is from 4 to 12, I get away with it without having to worry about the turning point. So what's the reason behind that? Yes, Ubaidullah, your answer is correct. So the reason why I get away here is because it's a one-to-one function. Okay? Here, why don't I get away with this method? Because it's not a one-to-one function. Here, why do I get away with this method? Because it's a one-to-one function. So what is the standard rule? Tell me now if you guys can come up with a standard rule.
So it can be like if there's no turning point involved in your range, then the function would be one-to-one.
TK, that's correct. All right, anyone else? But my standard rule is connected with the way that you find out the range. How will you make a standard rule for finding out the range? That's what my question is. If a function is one-to-one, we can find the range. Yeah, that's correct. So here is the standard rule. If a function is one-to-one, you can find out the range by plugging in the endpoints of the domain. If, however, a function is not one-to-one, if it's a many-to-one function, then the best way to find out the range is to make a sketch so that you can see the turning point. Okay? So let's write this down. Okay. In order to find out the range of a one-to-one function, we can plug in the two end points or extreme points, doesn't matter, of the domain and give answer in range form. However, in fact, let's make it another note. In order to find out the range of a many-to-one function. So let me answer your question in a minute. Let me write this down. We have to make a sketch to find the... it's not necessary that we make a sketch to find out the minimum point. Okay, that depends on the shape of the curve. It could be the minimum or maximum point before giving the range. Okay, so we can't know without the graph whether it's one-to-one. So you can. Okay, you can. How? Let me show you. And you can only know that for a quadratic curve. Okay, so what does a quadratic curve look like? This is what it looks like. Okay, so this is what a quadratic curve looks like. What are the coordinates of the turning point? H comma k. Okay, here's H and whoops. Here's k. Okay. Yeah, I'll scroll up. Let me just get through this. I'll scroll up. Okay. So f of x is a quadratic function. This is a quadratic function here. F of x. Now, if the domain is such that x belongs to the set of all real values, that means it's a many-to-one function. However, if I alter the domain, and let's say I only allow you to look at the part that is after the turning point, what does that make it? That makes it a one-to-one function. Again, if I alter the domain in such a way that I only allow you to look at the part of the curve before the turning point, that also makes it a one-to-one function. So if you have a quadratic curve, and given that you found out its turning point, then you can look at the domain and see if the x-coordinate of the turning point falls inside the domain, it's a many-to-one function. If the x-coordinate of the turning point is outside the domain, then it's a one-to-one function. Okay? You might want to write this down as well. Let's write this down. If it's not quadratic, then it's best to make a sketch. Your safest bet is always to make a sketch. Okay? Your safest bet is always to make a sketch. So note, if x coordinate of turning point, which is h, is inside the domain, then that makes it a many-to-one. However, if x coordinate of turning point h is outside the domain, that makes it a one-to-one. Okay, so a lot of information for one day. Here, take a good look at it. Acha, Moiz, even if it's greater than or equal to or lesser than or equal to, it makes no difference. Okay? So it doesn't matter whether it's greater than or less, greater than equal to, or lesser than equal to. Okay. The thing is, the curve will, for that range, be either an increasing function or a decreasing function. So having that equal to sign won't change that. Okay, so let me know when you're done having a look. Reach. Why is function more of like theoretical chapter, not practical? Good question. Why is it more? Because the thing is, there are a lot of exceptions. Like, for example, plugging in the endpoints of the domain. Can we do that all the time? No. Okay. Can we do it for specific functions? Yes. So the question is, why can we do it for some function and why not for the other? So for that, you need to understand what is a one-to-one function in detail. A one-to-one function is a function that is either only increasing or only decreasing. Okay, but if a function between two endpoints is doing both, then you can't plug in the endpoints and expect that one endpoint will give you the maximum or minimum value and the other endpoint will give you the other value. It doesn't make sense. So like, for example, here, because 3 to 5 is a one, from 3 to 5 it's a one-to-one function. That means if I plug in 3, I get the minimum value, and if I plug in 5, I get the maximum value. However, between -2 and 3, I can't expect -2 to give me, well, -2 does give me the maximum value for this range, but I can't expect 3 to give me the minimum value. The minimum value we get is before 3. Why? Because from -2 to 3, it's not a one-to-one function, it's a many-to-one function. So you have to make sure that you understand all of this in detail. Because it's the same thing that we did for trigonometry. We're going in detail so that later on we don't struggle with the basic concepts. Okay? If we start making a lot of rules for ourselves, then we'll lose the essence of this topic.